quick review on the properties of exponents for any real numbers, x and y, integers a and b. So let's refresh on the product of powers rule. X to the power a times x to the power b. Make sure the bases are the same before you apply the product of powers rule. So x to the power a times x to the power b, we have the same basis. So this is simply equal to x to the power a plus b. So you add the powers if you have the same bases multiplied together. For example, 3 squared times 3 to the 4th is equal to 3 squared plus the 4, so it's 3 to the 6th. Now, let's explain why this is true. Okay, so 3 squared times 3 to the 4th. Simply, 3 squared is 3 times 3. 3 to the 4th is 3 times 3 times 3 times 3, 4 times. So, looking at it, how many times is 3 multiplied by itself? 1, 2, 3, 4, 5, 6. Feel free to use it with any number to verify it. Quotient of powers rule. Again, you need to make sure the bases are the same before you apply the quotient or the power rule. So, x to the power a divided by x to the power b. Of course, fractions is also division. This is equal to x to the power a minus b. Remember, we cannot divide by 0, so x can never be a 0. Example, 9 to the power 5 over 9 to the 2nd, or squared, is equal to 9 to the power 5 minus 2, or 9 to the 3rd. Again, let's prove it. 9 to the 5th over 9 to the 2nd, or squared, is equal to 9 times 9 times 9 times 9, 5 times. Divided by 9 squared is simply 9 times 9. Now, when we simplify, 9 divided by 9 is 1. 9 divided by 9 is also 1. So this is equal to 1 times 1 times 9 times 9 times 9, simply 9 to the 3rd. So it's 9 cubed. Again, feel free to verify it with any numbers you like. The negative exponent. Anytime you see a negative exponent or a negative power, you need to find the reciprocal of the term. Example, x to the power negative a equals to 1 over x to the power a. Remember, reciprocal means you flip the fraction. So basically, this is x divided by 1, or over 1. So the reciprocal is 1 over x to the power a. As well as 1 over x to the power negative a, the reciprocal will be just x over 1, which is simply x to the power a. Remember, we can never divide by 0, so x can never be a 0. Example, 3 to the power negative 5, this is equal to 1 over 3 to the power 5. This is not a new rule. We learned it last year. Email me if you have any questions. The power of a power rule. If x to the power a also has the power of b, this is simply as saying it's x to the power a times b. For example, 3 cubed all squared this is equal to 3 to the power 3 times 2, or simply 3 to the power 6. Now let's prove it. So 3 to the power 3, all to the power 2. Remember, parentheses means all of that has that power. So this is just like saying that I have 3 to the power 3 times itself. For square means 2 times. So 3 times 3 times 3, so this is 3 cubed. This is also 3 times 3 times 3. So how many times am I multiplying the 3's together? Simply 3 to the power 1, 2, 3, 4, 5, 6. Again, feel free to verify it with any numbers. Power of a product is simply saying that if x times y, included in parentheses, all to the power a, is the same as saying that x to the power a times x to the power y. Example, 2 times k all to the fourth is the same as saying 2 to the fourth times k to the fourth, or 16k to the fourth. Okay, let's prove it. It's 2k to the fourth, simply saying that I'm multiplying 2k by itself 4 times. So 2k times 2k times 2k times 2k. Okay, so 2 times 2 times 2 times 2 is simply 16, and you have 4 k's. Okay, power of a quotient. Very similar, but this time you're dividing x divided by y all to the power a, simply saying x to the power a divided by y to the power a. Remember, we cannot divide by 0, so y can never be 0. So, x over y all squared, simply saying x squared divided by y squared. And my bases are not the same, so I can't really combine the bases. So let's prove this. X over y all squared is the same as x over y times itself. So this is equals to x squared divided by y squared. Let's do it with numbers. 2 over 3 all squared equals to 2/3 times 2/3, which is 2 squared over 3 squared, simply just 4 over 27. The zero power property, this is not new to us, we've learned it last year, simply saying that any real number to the power 0 is equal to 1. Okay? For one exception, it cannot be 0. So any number other than 0 to the power 0 is 1. Example, 7 to the power 0 is a 1.